In our last session, we discussed the real number system and how to geometrically represent it using a real number line. In today's session, we use two of those real number lines to construct a rectangular coordinate system. We will see how we can use this to visually represent points, which are ordered pairs of numbers. We then do a brief review of the Pythagorean theorem and then use it to derive the formula for calculating the distance between any 2 points on the rectangular coordinate system. We conclude this session by learning how to find the middle point between any 2 points in the rectangular coordinate system. Let's delve right in. We use the real number line to graphically represent numbers from the real number system. Now, what if we have two numbers that come as a pair? If these pairs have a fixed order to them, these mathematical objects are called ordered pairs and are written as two numbers inside parentheses. We use a rectangular coordinate system to graphically represent them. To construct a rectangular coordinate system, we draw two lines perpendicular to one another. The point of intersection of these lines is called the origin. The horizontal line is called the x-axis, and the vertical line is called the y-axis. We use the notion of unit distance that we described in the previous video to build out the coordinate system. The segment of the x-axis to the right of the origin is called the positive x-axis. The segment to the left of the origin is called negative x-axis. The segment of the y-axis above the origin is called the positive y-axis. And the segment of the y-axis below the origin is called negative y-axis. We now have a full rectangular coordinate system. Let's now plot the point 1, 2. For that, we first draw a vertical line parallel to the y-axis such that it crosses the x-axis at point 1. We then draw a horizontal line parallel to the x-axis such as it crosses the y-axis at the value 2. The point where both of these lines intersect is where the point 1, 2 is. So for any given point with coordinate values x and y, we can plot them on the rectangular coordinate system. The value x is called the x-coordinate or abscissa, and the value y is called the y-coordinate or ordinate. Now, the rectangular coordinate system is also called an xy plane. For us to be able to calculate how close or how far apart 2 points on the xy plane are, we need the Pythagorean theorem. Let's do a quick review. The theorem states in any right-angled triangle, the sum of the squares of its legs equal the square of its hypotenuse. Here is a right-angled triangle with base A and height B and hypotenuse C. The theorem says that a squared plus b squared equals c squared. Let's do a quick proof of this theorem. Let's make 4 copies of this right triangle about and arrange it along the 4 corners of a square with side A plus B. This arrangement forms another square of side C inside the larger square. The area of the big square with side A plus B is A plus B squared, and that is equal to the area of the small square plus the areas of the 4 right-angled triangles. So that gives us A plus B squared equals C squared plus 4 times half AB. Using the binomial expansion, we expand the left-hand side of the equation. We get A squared plus B squared plus 2AB equals C squared plus 2AB. Now, subtracting 2AB from both sides, we get A squared plus B squared equals C squared, which is the Pythagorean theorem. We can directly apply the Pythagorean theorem to calculate the distance between any 2 points on the xy plane. Let P1 be a point with the x-coordinate x1 and y-coordinate y1, and let P2 be a point with x-coordinate x2 and y-coordinate y2. We can think of P1 and P2 to be in the corners of a right-angled triangle. Now, the hypotenuse of this right-angled triangle will give us the distance between P1 and P2. The base of this right-angled triangle will be x2 minus x1, and the height will be y2 minus y1. Let D be the hypotenuse of this triangle. Now, directly applying the Pythagorean theorem, we get D squared equals x2 minus x1 square plus y2 minus y1 square. Taking square root on both sides, we get the distance D equals square root of x2 minus x1 square plus y2 minus y1 square. Now, since distance is a positive quantity, we only keep the positive root. We now have the ability to find the distance between any 2 points on the xy plane. What if we want to find the midpoint between 2 points? We can use the picture we drew earlier to find the midpoint of the line segment joining the 2 points P1 and P2. We can get the x-coordinate of the middle point by taking the average of x1 and x2. Likewise, we can calculate the y-coordinate of the middle point by taking the average of y1 and y2. Thus, the midpoint coordinate P is x1 plus x2 by 2, y1 plus y2 by 2. That's all I have in this session. Thank you for tuning in. Talk to you soon.